The first Neanderthal remains were discovered by Dutch naturalist Philip Charles Schmerling in 1829. He assumed it was a fossil of a Homo sapiens skull. Later in 1849, Gibraltar I was discovered, though it too was thought to be a modern human skull. Finally, in 1856, schoolteacher Johann Karl Vollrath recognized that bones discovered in the Neander Valley were distinct from that of Homo sapiens. The remains were then handed to German anthropologist Hermann Schaffhausen to study them in 1857. They comprised of the cranium, thigh bones, right arm, left humerus, ulna, left elum, part of the shoulder blade, and pieces of the ribs. Following Charles Darwin's On the Origin of Species, Vollrath and Schaffhausen argued that the bones represented an ancient modern human form. With only a single individual, it was argued that it was just a Homo sapien with various illnesses. This view would stall Neanderthal research until the end of the century. However, by the early 20th century, numerous other Neanderthal discoveries were made, establishing Homo neanderthalensis as a legitimate species. The first reconstructions describe Neanderthals as slouching, ape-like, and only remotely related to modern humans. But by the middle of the century, further scientific studies began to rework our understanding of our long-lost relatives. Gradually, a more human-like picture of Neanderthals began to emerge. Hybridization between Neanderthals and early modern humans had been suggested as early as 1890 and was eventually proved to be true. Neanderthals are hominids in the genus Homo. They are generally classified as their own species, Homo neanderthalensis. Sometimes they are considered as a subspecies of modern humans as Homo sapiens neanderthalensis. This would make us Homo sapiens sapiens. They can be considered a distinct species because of the absence of Neanderthal-derived patrilineal Y chromosome and matrilineal mitochondrial DNA in modern humans, along with the underrepresentation of Neanderthal X chromosome DNA. It is hypothesized that this would have caused a reproductive barrier to where some hybrids would be sterile. Obviously, not all of them were, though, as traces of admixture can be found in almost all modern human groups, excluding some sub-Saharan Africans. Neanderthals were more closely related to Denisovans. Denisovans are also considered their own distinct species by many. It is largely thought that Homo heidelbergensis was the last common ancestor of Neanderthals, Denisovans, and Homo sapiens before populations became isolated in Europe, Asia, and Africa, respectively. The distinction between heidelbergensis and Neanderthals is mostly based on fossils in Europe between about 300,000 and 243,000 years ago. Neanderthals are typically fossils that appear during and mainly after this period. However, bones from Cima de los Huesos that date to 430,000 years ago might represent the earliest hominids considered to be Neanderthal. 400,000-year-old remains of Aero Era 3 could represent a transitional phase. Ancestral and derived morphs could have lived concurrently. The fossil record of Neanderthals is much more complete from 130,000 years ago onwards. Most specimens are known from this period. The reason Neanderthals became distinct from sapiens and even Denisovans is likely due to the climate of Europe and the Near East during the time. Their environment was very cold due to our planet being in an ice age for the past 2.5 million years. This caused them to adapt to the colder conditions anatomically. Our last common ancestor with Neanderthals split off about 500,000 years ago. They then split from Denisovans as late as 470,000 years ago or as early as 200,000 years ago. Before splitting, Neanderthal Denisovans or Neanderthals migrating out of Africa into Europe apparently interbred with an unidentified super-archaic human species. These super-archaics were the descendants of a very early migration out of Africa around 1.9 million years ago. Neanderthals would then expand into a fairly large range, although their population was quite small. They are recorded living in Western, Central, Eastern, and Mediterranean Europe, as well as Southwest, Central, and Northern Asia up to the Altai Mountains in southern Siberia. The southernmost find was recorded at Shukba Cave, Levant. Their easternmost presence is recorded at Denisova Cave, Siberia. They also lived as far north as the British Isles and possibly as far as southern Scandinavia. But for much of their existence, these areas were covered in glaciers. To add to this, the evidence of their occupation of these areas may have been destroyed by glaciers. Like mentioned earlier, their population was quite small. Various studies using mtDNA analysis yield very ineffective populations, such as about 1,000 to 5,000, 5,000 to 9,000 remaining constant, or 3,000 to 25,000 steadily increasing until about 52,000 years ago before declining until extinction. Their population was only a tenth of the size of contemporary sapiens. Neanderthals were robust and stocky compared to modern humans. They had barrel-shaped rib cages and wider pelvises. Their forearms and forelegs were also proportionally shorter. Based on 45 Neanderthal long bones from 14 men and 7 women, the average height was 165 centimeters or 5 feet 5 for males. Females were shorter at 152 centimeters or 5 feet. For comparison, the average height of 28 male or 10 female Upper Paleolithic humans is 176 centimeters or 5 foot 9 inches for men. Women, on the other hand, were 163 centimeters or 5 foot 4 inches. The fossil record shows adult Neanderthals varied from about 147.5 to 177 centimeters or 4 foot 10 inches to 5 foot 10 inches. Some certainly grew larger, and a height of 182 centimeters or 6 feet was likely attainable. For Neanderthal weight, samples of 26 specimens found an average of 77.6 kilograms or 171 pounds for males and 66.4 kilograms or 146 pounds for females. The body mass index for Neanderthal males was calculated to be 26.9 to 28.2. which in modern humans correlates to being overweight. Though for Neanderthals, this just indicates a very robust build. The Neanderthal LEPR gene concerned with storing fat and body heat production is similar to that of the woolly mammoth. It was likely an adaptation for cold climate. The neck vertebrae of Neanderthals are longer and thicker than those of modern humans, lending to stability, possibly due to different head shapes and sizes. Body proportions are usually cited as being hyperarctic as adaptations to the cold, because they are similar to those of modern human populations which developed in cold climates. The Neanderthal build is most similar to that of the Inuit and Siberian Yupiks among modern humans. Nonetheless, Neanderthals from more temperate climates such as Iberia still retain the hyperarctic physique. In 2019, English anthropologist John Stewart suggested Neanderthals were adapted for sprinting. Their robust bodies may have allowed them to quickly run after prey. Neanderthals generally did prefer warmer wooded areas over the colder mammoth steppe. DNA analysis also indicates a higher proportion of fast-twitch muscle fibers in Neanderthals than modern humans. Stewart explained their body proportions and greater muscle mass as adaptations to sprinting as opposed to the endurance-oriented modern human physique, as persistence hunting may only have been effective in hot climates where the hunter can run the prey to the point of heat exhaustion. They had longer heel bones, reducing their ability for endurance running, and their shorter limbs would have increased the speed at which their muscles contracted. So they no doubt would have been good sprinters, but this may not be the only reason for their physique. Climate also definitely played a role. Another controversial aspect of their anatomy was their humerus. There has long been a debate in anthropology over the anatomy of Neanderthal humeri and whether it would have been efficient at throwing spears. Originally, evidence seemed to indicate that their shoulders could not overarm throw well. They were thought to be better adapted to thrusting. This was also backed up by how many wounds they received in their lifetimes. If they really did only stab their prey, then they would have had to get up close and personal with these very dangerous animals. However, this notion of stabbing big dangerous animals has been fading away. Berthaum et al. 2014 found that Neanderthal humeri were efficient at both thrusting and throwing. There was no evidence that thrusting was more prominent. It also found that sapien and Neanderthal humeri, although different, showed similarities in resisting throwing and thrusting stress. To add to this, the Shawinigan spears dating to over 300,000 years ago were found to be efficient throwing weapons. They were balanced and able to be thrown over 20 meters or 65 feet. Though they are often credited to European Homo heidelbergensis, these people would have been near indistinguishable from early Neanderthals because this is right around the time when their species appeared. We also know that Homo erectus, a distant ancestor of Neanderthals and sapiens, had efficient arms for throwing millions of years ago. All of this evidence seemed to indicate that they certainly could throw, and the Shawinigan spears indicate they did. They still would have been ambush predators, and certainly stabbed their prey when they got close. You could even imagine some Neanderthals out of the group were not that good at throwing, so maybe some would prefer to get up close and personal. And even if you spear a large animal, they still often have a lot of fight in them. Trying to finish off these animals would lead to the injuries that we do see in their remains. Neanderthals had bigger brains than modern humans. The Neanderthal brain case averages 1,600 cubic centimeters for males and 1,300 cubic centimeters for females. Modern humans average 1,270 cubic centimeters for males and 1,130 cubic centimeters for females. However, Homo sapiens specimens from between 190 and 25,000 years ago averaged about 1,478 cubic centimeters disregarding sex. Modern human brain size is suggested to have decreased since the Upper Paleolithic. The largest Neanderthal brain, Amud 1, was calculated to be 1,736 cubic centimeters, one of the largest ever recorded in hominids. Now I wonder if this guy was any smarter than any of his contemporaries, or if the brain matter was just used for other things. Interestingly, both Neanderthal and human infant brain cases measure about 400 cubic centimeters. In Neanderthals, the occipital lobe was much larger than in modern humans, and similarly they had larger eyes, probably as an adaptation to lower light conditions in Europe. More brain tissue was devoted to bodily maintenance and control, and consequently the cognitive areas of the brain were proportionally smaller than in modern humans. They would have been less proficient in language, attention, working memory, social abilities, and thought in general. How much so is up for debate. Since we obviously do not have a living specimen, it is very hard to say how smart they were. It is a great mystery how one of these people would fare in the modern day. If you were to acquire a Neanderthal baby, could you teach it English? Could it learn math? Could it socialize like a sapien? These are all very intriguing questions that we may never be able to answer. Depictions of Neanderthals were originally very primitive and ape-looking. In more recent years, we have discovered that Neanderthals were much more human-looking than once thought. Their faces differed from ours in a few general ways. They had a reduced chin, sloping forehead, and a large nose. The Neanderthal skull is typically more elongated and less globular than that of modern humans. They also had an occipital bun, a protrusion on the back of the skull, although it is within the range of variation for modern humans who have it. They had larger eyes, likely adapted to a low-light environment like previously mentioned. The large Neanderthal nose has generally been explained as having warmed air as it entered the lungs and retained moisture. Neanderthals featured a protrusion of the jaw known as prognathism. This may have been to make room for the large teeth that they had. Neanderthal dental wear patterns are most similar to that of the modern Inuit. The bite force of Neanderthals and modern humans is now thought to be about the same. The lack of sunlight in Europe led to the proliferation of lighter-skinned Neanderthals. These are the same forces that eventually led to the lighter-skinned European sapiens. Our bodies primarily synthesize vitamin D rather than getting it from food. Vitamin D is synthesized when UV rays from the sun enter our skin. Lighter skin absorbs more of this light while darker skin blocks it out. Europeans need lighter skin to get vitamin D from the limited sunlight they receive. African and other groups, on the other hand, have darker skin because they are subjected to intense sunlight every day. Too much sunlight damages cells and can lead to cancer. For this reason, human skin color varies depending on the environment. Neanderthals primarily live in northern areas and thus needed lighter skin. They did live closer to the equator in places such as the Mediterranean and the Middle East. These populations had darker skin and hair. The DNA of 3 Croatian Neanderthals show they had darker hair, skin, and eye color than modern Europeans. MC1R is a receptor gene that controls the production of melanin, the protein responsible for pigmentation of hair and skin. Neanderthals had a mutation in this receptor gene which changed an amino acid, making the resulting protein less efficient and likely creating a phenotype of red hair and pale skin. Modern humans display similar mutations of MC1R, and people who have 2 copies of this mutation have red hair and pale skin. No modern human has the exact mutation that Neanderthals had, which means that both Neanderthals and Homo sapiens evolved this phenotype independent of each other. Some groups of Neanderthals certainly had red hair, such as in Italy and Spain. However, as in modern humans, red was probably not a very common hair color because the variant is not present in many other sequenced Neanderthals. Genetic analysis indicates that there were at least 3 distinct geographical groups: Western Europe, the Mediterranean coast, and east of the Caucasus. These 3 populations differed anatomically. Southern Neanderthals exhibit regional anatomical differences from that of their northern counterparts: a less protrusive jaw, a shorter gap behind the molars, and a vertically higher jawbone. Neanderthals living west of the Altai Mountains also had their own differences. This suggests Neanderthal communities regularly interacted with neighboring communities within a region, but often not far beyond. Nonetheless, over long periods of time, there is evidence of large-scale cross-continental migration. Early specimens from Mezmaiskaya Cave in the Caucasus and Denisova Cave in the Siberian Altai Mountains differ genetically from those found in Western Europe, whereas later specimens from these caves both have genetic profiles more similar to Western Europe Neanderthals. Similarly, artifacts and DNA from other caves also in the Altai Mountains resemble those of Eastern European Neanderthal sites about 4,000 kilometers or 2,500 miles away. This suggests 2 distinct migration events into Siberia. Neanderthals are considered to be the apex predators of their environment. They would get close to their prey or wait for their prey to get close to them, and then in a powerful burst of speed throw or thrust their spears into their prey. Younger or wounded animals may have been hunted using traps, projectiles, or pursuit. Over their vast range, they employed a variety of hunting and gathering techniques. Communities on the Mammoth Steppe would primarily eat large game with a variety of local plants. Forest-dwelling communities would have consumed a wide array of plants and smaller animals such as deer and rabbit. Tribes living on or around the Mediterranean would consume aquatic resources. Generally, their diet seemed to be less varied than that of sapien hunter-gatherers, but still varied enough to ward off nutritional deficiencies. For many communities during the winter, lean meat would have been about the only thing around to eat. They would have supplemented by eating fat-rich grains, roots and tubers, and the stomach contents of herbivorous prey animals. Plants which have been semi-digested by these herbivores would have been a good source of nutrients for these people. Though it sounds odd, it is a practice still done by the Inuit who have little access to plants during the winter. They fed primarily on hooved animals. Red deer and reindeer were consumed most frequently, and they were the most abundant. Other game included ibex, Irish elk, wild boar, aurochs, mammoth, straight-tusked elephant, and woolly rhino. There is evidence of directed cave and brown bear hunting both in and out of hibernation, as well as butchering. Analysis of Neanderthal bone collagen from Vindiša Cave, Croatia shows nearly all of their protein needs derived from animal meat. Some caves show evidence of regular rabbit and tortoise consumption. At Gibraltar sites, there are remains of 143 different bird species, many of them ground-dwelling. Neanderthals also exploited marine resources on the Iberian, Italian, and Peloponnesian peninsulas, where they waded or dived for shellfish. At Vanguard Cave, Gibraltar, the inhabitants consumed Mediterranean monk seal, short-beaked common dolphin, common bottlenose dolphin, Atlantic bluefin tuna, sea bream, and purple sea urchin. You may be wondering, how did they manage to catch such animals? Well, paleontologists are still wondering. Seals can be caught once they come ashore, and beach dolphins would have been easy prey. Fish can be caught with nets and hooks. At Gruta da Figueira Brava, Portugal, there is evidence of large-scale harvest of shellfish, crabs, and fish. Evidence of freshwater fishing was found at Grotte di Castelcivita, Italy for trout, chub, and eel. As many of you know, fishing is not easy. Fish are smarter than you think, and they are really good at escaping once caught. The wide variety of fish caught by this people tells us that they might have employed a wide variety of tactics to catch them. The presence of all these fish remains indicate that they may have had better fishing technology than once thought. Besides hunting and fishing, they also foraged often. Edible plant and mushroom remains are recorded from several caves. Neanderthals from Cueva del Cedrón, Spain, based on dental tartar, likely had a meatless diet of mushrooms, pine nuts, and moss, indicating they were forest foragers. Remnants from Amity Cave, Israel indicate a diet of figs, palm tree nuts, and various cereals and edible grasses. It's amazing to think that some groups may have been more or less vegetarians. Others were hyper-carnivores who hardly touched green plants. Dental tartar from Grota de Spy, Spain, indicates the inhabitants had a meat-heavy diet including woolly rhinoceros and mouflon sheep, while also regularly consuming mushrooms. The oldest known human fecal matter remains show that a particular group in Spain ate mainly meat and plant matter. Evidence of cooked plant foods, including legumes and acorns, has been found in Israel. Many groups of Neanderthals were quite nomadic, likely due to their hunting and foraging needs. At Shanidar Cave in Iraq, Neanderthals collected plants with various harvest seasons, indicating they scheduled returns to the area to harvest certain plants. This indicates that they had complex food-gathering behaviors for both meat and plants. To be a hunter-gatherer required a deep knowledge of your land and an expansive mental map of your environment. These people were certainly masters of survival, but they didn't survive unscathed. Neanderthals faced ruthless competition with the other Ice Age predators. They coexisted with most of these predators for about 200,000 years. This tells us that neither the ruthless predators nor the Neanderthals pushed each other to extinction. Regardless, competition would have been fierce. Cave lions as large as the biggest tigers targeted horses, large deer, and wild cattle. Homotherium, known as the scimitar cat, hunted young mammoths and other fairly large game. Wolves would have hunted a variety of prey. Leopards mainly targeted reindeer and roe deer. This heavily overlapped with the diet of Neanderthals. Fortunately for our evolutionary cousins, leopards are solitary creatures, so defending a kill from them would have not been very difficult. However, the other predators certainly craved our kills. To deter such predators, Neanderthals likely engaged in intimidation tactics such as yelling, arm waving, and stone throwing. Being able to quickly harvest game was a necessity for these people. Deer and other small game could be dragged off, but larger game would have put them at a higher danger of encounters with lions or hyenas. They were not helpless in their skirmishes with rival predators. The remains of wolves, cave lions, and cave bears, which were all major predators of the time, indicate Neanderthals hunted their predators to some extent. Neanderthals and cave hyenas might have actually exemplified niche differentiation. They would have actively avoided each other when they could. Animal remains from Neanderthal caves indicate they targeted prime individuals while hyenas hunted weaker or younger prey. Nonetheless, in typical hyena fashion, encounters over food would have become hostile and may have been a large factor in how Neanderthals protected their kills. Remains of Neanderthals indicate that they were either preyed upon or scavenged by these powerful beasts. In addition to ruthless hyenas, bears were certainly to be feared by these people. Cave bears stood 3.5 meters or nearly 12 feet in height. They also weighed up to 1,000 kilograms or 2,200 pounds. However, cave bears were mainly herbivores that hunted very rarely, and most of the remains they ate would have been scavenged. Still, such a powerful animal would have been hard to stop even with a whole tribe of spear-wielding Neanderthals. Remains indicate that bear hunts may have been a cultural practice among some groups. Regardless of all of the formidable predators that occupied their lands, Neanderthals seemed to thrive alongside them. At Grotte du Lazaret in France, a total of 23 red deer, 6 ibexes, 3 aurochs, and 1 roe deer appear to have been hunted in a single autumn hunting season. The entire carcasses seem to have been transported to the cave and then butchered. Because this is such a large amount of food to be consumed, it is possible these Neanderthals were curing and preserving the food before winter set in. The evidence is 160,000 years old, and it is the oldest potential evidence of food storage. It would make sense that they were capable of preserving their food. A whole mammoth or woolly rhino would have left substantial leftovers for even a whole tribe of Neanderthals. Neanderthals seem to have cooked most of their food. They roasted meat and plants and likely even created stews. The abundance of animal bone fragments at settlements may indicate the making of fat stocks from boiling bone marrow, possibly taken from animals that had already died of starvation. This would have been a very important meal because fat was a hot commodity for Neanderthals. Many groups were basically on a ketogenic diet for most of the year. Lean meat would have had to be supplemented with fat. This bone broth would have been a good way to do it. Neanderthal tooth size had a decreasing trend after 100,000 years ago, which would indicate an increased dependence on cooking or the advent of boiling, a technique that would have softened food. It is important to note this because many get the notion that Neanderthals were stagnant beings that never progressed. In reality, just like sapiens, we see trends of evolution within their species. At Cueva del Cedrón, Spain, Neanderthals likely cooked and possibly smoked food, as well as used certain plants such as yarrow or chamomile as flavoring. This is not for certain, as these plants could have been used as medicine. With shellfish, Neanderthals needed to eat, cook, or in some manner preserve them soon after collection, as shellfish spoils very quickly. At a cave in Spain, there is evidence that they are keeping these shellfish alive in water-soaked algae. It blows my mind that these people ate so much seafood. The classic picture of a Neanderthal hunting big game is true, but it leaves out the diversity of diets between groups. Their diet was so diverse, in fact, that they even ate each other. There are several instances of Neanderthals practicing cannibalism across their range. Examples come from Croatia, Spain, France, and Belgium. 5 cannibalized remains of Neanderthals in Belgium met a gruesome fate. There is evidence that their upper limbs were disarticulated and the lower limbs smashed and the chest cavity disemboweled. About 35% of the Neanderthals at Marillac-le-Franc, France, show clear signs of butchery, and the presence of digested teeth indicate the bodies were abandoned and eaten by scavengers later. Based on this evidence, it would be easy for one to make the assessment these people were brutish cannibals. Closer examination of the evidence shows that the high number of cut marks present on the Neanderthal individuals indicate a lack of experience in butchering human carcasses. To aid to this, total cannibalized individuals are actually quite small when compared to the total number of fossils we have. Cannibalism would have not been a very common practice. Other groups may have gone many generations without tasting the flesh of their kin. Anthropologists interpret this behavior in a few ways. Ritualistic behavior, pre-burial defleshing to deter scavengers, an act of war, or simply for food. And before you place judgment on these people, let me say this. Homo sapiens, just like our Neanderthal cousins, are also cannibals. Archaeological evidence has shown that thousands of years ago we were partaking in similar behaviors. And of course, even in modern times, cannibalism happens, and not just out of desperation. There have been whole societies that eat people in both ritualistic and non-ritualistic ways. For example, the Aztecs were known to partake in ritualistic cannibalism. Our disgust towards this practice is due to our culture rather than it being objectively wrong. At the end of the day, we are made out of meat, and whether it be hard times or a strange religious worship, cannibalism is a natural human behavior. So when looking at the evidence of Neanderthals eating each other, do not make generalizations about the species. Even if some groups ate people, some may have been just as disgusted as you or I at the idea of eating their kin. Fire was one of the most important technologies these people possessed. Many Mousterian sites have evidence of fire, and some for extended periods of time. It is unclear if they were capable of starting their own fires. They could have scavenged them from naturally occurring fires. Indirect evidence of fire technology includes pyrite residue on a couple dozen bifaces. When flint is struck against this material, sparks fly. These sparks could be harnessed into a combustible material to produce fire. It is a skillful and hard process, but we know these people were capable of a lot. The amount of evidence of fire found at Neanderthal sites, some only inhabited during the winter, tell us that fire was likely not just harvested from natural wildfires. It is pretty safe to say that at least some bands would have been able to produce fire. Hearths have been discovered in a number of caves. Neanderthals likely considered air circulation when making these hearths. At a site in Spain, 8 evenly spaced hearths, lined up against the rock wall, were likely used to stay warm while sleeping, with one person sleeping on either side of the fire. Other caves show evidence that smoke was let out of the cave through natural ventilation. We have evidence that a lot of their food was cooked, especially animal remains. Even plants were cooked as mentioned in the food section. Fire was certainly one of the most important technologies that these people possessed and helped them survive in many ways. But it was only one of their tools. Neanderthals made a wide array of tools to thrive in their world. And these tools did not stagnate. They changed as the years passed and the technology progressed. They are credited with creating the Mousterian industry, a more complex and advanced form of working stone. It evolved from the level Y industry about 160,000 years ago. The level Y was its close predecessor, and the two are sometimes considered as one. The level Y industry made it easier to control flake size and shape, and as a difficult-to-learn process, the level Y technique may have been directly taught generation to generation rather than purely on observational learning. There is a relatively high diversity in Neanderthal stone tool production that we don't see in other hominid species for thousands of years. Proposed explanations include unique ethnic traditions and a diversity of uses. For example, a tool that is good at killing a deer may not fare well in killing an elephant. Given that the Neanderthal diet varied from rabbit to seals to elephant, it makes sense that there would be diversity in tool production. Stone tools included disc-shaped cores, flake tools, well-made scrapers, and triangular points that were used as knives. Denticulate tools were made to serve as saws. They could be used to make notches in wood or to saw it in half. Round limestone balls found at Neanderthal sites are believed to serve as bolas, a weapon used to this day consisting of 3 balls at the end of a string that can trip animals. Weapons to actually kill game varied. Wooden spears lacking a stone tip were certainly in use throughout Neanderthal existence. More complicated hafted stone tips did become more common later in Neanderthal technological tradition. 55,000 years ago, towards the twilight of Neanderthal existence, they created leaf-shaped stone tips that were hafted on spears. They were likely used as thrusting weapons. The wide point would have been exceptional at causing massive blood loss for prey. These points in particular were hafted on wooden shafts, used, reshaped, perhaps used again, and then finally discarded. They were hafted with plant-based glue and bindings made from plant fibers. They would have been deadly tools, and couple them with the pure strength of a Neanderthal, and even a Paleoloxodon has reason to fear. There is still some debate if Neanderthals had long-range projectile weapons. We do know that their arms could throw, so it is certainly a possibility. A wound on the neck of an African wild ass from Syria was likely inflicted by a heavy javelin. Some spear tips from France may have been too fragile to have been used as thrusting spears, suggesting their use as darts. Bone trauma consistent with habitual throwing has been reported in Neanderthals. Even if they mainly used their big spears for thrusting, it would seem only natural that these people would have at least thrown some stones at their prey. Neanderthals worked with bone, but only in a limited way as far as we know right now. They used the ribs of large herbivores to create litho ears, a tool which is rubbed against the hide to make it more supple and waterproof. Though these litho ears could be made from the abundant reindeer for which they hunted, they preferred more uncommon bison and aurochs ribs. Another technology that were preferred were clamshell scrapers. Neanderthals in Italy preferred a certain species of clam to create these scrapers. They likely chose them because they were the most durable. At Grotte dei Mercerini, Italy, about 24% of the shells were gathered alive from the sea floor, meaning these Neanderthals had to wade or dive into shallow waters to collect them. Another extremely important aspect of their technology was cordage. Cordage allows for the production of nets, containers, baskets, ties, straps, clothes, shoes, bedding, snares, fishing, seafaring, and crafting of tools. In France, there is evidence of twisted fibers and a 3-ply inner bar fiber cord. It is unclear how widespread this technology was, considering the materials are biodegradable and preserve very poorly. This technology could indicate at least a very basic knowledge of weaving and knotting. The oldest direct evidence of cord is about 52,000 years old. However, 115,000-year-old perforated shell beads possibly strung together to make a necklace are the oldest indirect evidence. Neanderthals also made containers out of animal hide, birch bark, and even tortoise shells. Poor tortoise. Neanderthals were able to survive in a similar range of temperatures as modern humans while sleeping. In an enclosed space lacking any clothes, they still would have needed a temperature of about 28 degrees Celsius or 82 degrees Fahrenheit. Neanderthals lived through a number of glacial and interglacial periods. Interglacial periods would have been warmer but still would have had required Neanderthals to find some external source of warmth. The Eemian interglacial was a warmer period right before the last glacial period. In July, the average temperature would have only been about 17.4 degrees Celsius or 63.3 degrees Fahrenheit. In January, it would have gotten as cold as negative 30 degrees Celsius or negative 22 degrees Fahrenheit. And remember, this is a warm period. Neanderthals went through at least 3 much colder glacial periods. Danish physicist Bent Sorensen hypothesized that Neanderthals required tailored clothing capable of preventing airflow to the skin, especially during extended periods of traveling such as a hunting trip. Tailored footwear completely enwrapping the feet would have been necessary. But interestingly, bone sewing needles and stitching awls seem to be absent from the Neanderthal fossil record. Hide scrapers are very common, and the aforementioned lissow ears were used to work hides. They certainly used hide as clothing, but the technology may have been very limited. There is no direct evidence that they had fitted clothes, but indirect evidence definitely supports it. Indirect evidence of tailoring by Neanderthals includes the ability to manufacture string. This may indicate a weaving ability. Also, a naturally pointed horse metatarsal from Spain has been speculated to have been used as an awl. Regardless, there is just no way that they could have survived in the winter unless they hid in caves the whole time. And even then, they would have needed a constant supply of logs to stay warm. To actively hunt in the winter, which we are sure they did, they would have needed to cover about 80 to 90% of the body. Fitted shoes, gloves, pants, coats, and hats would have been necessary to ward off frostbite. They were thicker than us and able to conserve more body heat, but frostbite would have still been a major threat. Since sapien and Neanderthal admixture is known to have occurred in the Middle East, and no modern body-louse species descend from that of Neanderthal counterparts, it is possible Neanderthals in hotter climates did not wear clothes, or Neanderthal lice were highly specialized. For the harshest parts of the winter, Neanderthals actually may have hibernated. Though it sounds crazy, that is exactly what new research suggests. Researchers argue that lesions and other signs of damaged and fossilized bones of Neanderthals are the same as those left in the bones of other animals that hibernate. They suggest that our predecessors coped with ferocious winters at the time by slowing down their metabolism and sleeping for months. Evidence suggests that bone growth wasn't consistent throughout the year, which would line up with the idea that these early humans were dormant. It is a theory that has many in the scientific community intrigued, though several of the scientists desire more research to be done. If conclusively proven, it would vastly change how we view these people. Neanderthals were not limited to caves. Though caves were great shelter, especially during the colder months, shelter was created by these people. A 44,000-year-old site in Ukraine shows evidence of a 7-meter by 10-meter ring-shaped dwelling made out of mammoth bones meant for long-term habitation by several Neanderthals, which would have taken a long time to build. It appears to have contained hearths, cooking areas, a flint workshop, and there are even traces of woodworking. Upper Paleolithic modern humans in Russian plains are thought to have also made housing structures out of mammoth bones. Their caves were also not just holes in the ground. A cave in Barcelona, Spain has given us an insight into what their homes would have been like. Archaeologists have uncovered what they think is a hole located near hearths that could have been used to heat water. Other remains show evidence of sleeping areas, trash disposal areas, and areas used for creation of stone tools and even slaughtering animals. Bands likely moved between certain caves depending on the season, indicated by remains of seasonal materials such as certain foods, and returned to the same locations generation after generation. Some sites may have been used for over 100 years. Cave bears may have greatly competed with Neanderthals for cave space, and there is a decline in cave bear populations starting 15,000 years ago onwards. Although Neanderthals are generally considered to have been cave dwellers with their home base being a cave, settlements near the cave were likely favored in warmer months. Since they were hunter-gatherers, it is not always an option to stay in one place all year round. This is why Neanderthals were fairly mobile people at different times of the year. One of the most fascinating behaviors that truly highlights their technology was their seafaring ability. Middle Paleolithic stone tools on Greek islands indicate Neanderthals may have been seafaring as far back as 200 to 150,000 years ago. Artifacts on Crete date back to 130 to 107,000 years ago. Crete has been an island for some 5 million years and is 40 kilometers away from its nearest neighbor. This suggests ambitious journeys requiring some type of boat and prior planning. They could have used dugout canoes, reed boats, or even just a flotation device. The most likely would be some type of reed-based craft, although they could have tied multiple logs together as well. Other islands also show evidence of long-distance travel over the Mediterranean. Zakynthos and Cephalonia also have artifacts older than 100,000 years. Sardinia, Melos, Alonsos, and Naxos may have also been visited. Even the Strait of Gibraltar may have been crossed. If they really did cross the seas, their ability to engineer boats and navigate through open waters would speak volumes to their advanced cognitive and technical skills. Neanderthal fossil evidence displays an extensive record of skeletal injuries. It is generally accepted that more than 80% of the skeletal remains known to archaeologists display several injuries. The main source of food for many Neanderthals were hulking beasts. The hides of rhinos and mammoths were so thick that projectiles would have been less effective than actually going up and just stabbing the dang thing. But they would have had to get dangerously close to do sufficient damage. These animals could have broken limbs with the swing of their head, not to mention what would happen if you were to be trampled. In other regions, they hunted game in mountainous terrain that would have put them at risk of falling. Predators are also often a very deadly source of injury. As apes, they were not physically adapted to hunting such large and dangerous game. Fortunately, given their intelligence, they were able to overcome injuries with a variety of healthcare techniques. Bone fractures often healed without significant deformities, suggesting that they had been set with some sort of splint. It seems they may also have had a way to prevent blood loss from major injuries. Individuals with severe head and rib traumas would have needed some manner of dressing to prevent death. Bandages made out of animal skin may have been used. Some Inuit groups today use rodent skin to dress wounds. It's feasible that Neanderthals would have also come across similar methods to stop blood flow and keep the wound relatively hygienic. By and large, they appear to have avoided severe infections, indicating good long-term treatment of such wounds. The high level of injury and recovery from serious conditions, such as a broken leg, suggests that others must have collaborated in their care and helped not only ease their pain, but fight for their survival in such a way that they could regain health and actively participate in the group again. Neanderthals lived in small groups, so any loss of life was particularly devastating to the survival of the whole community. Injury over disease was the most common threat, as Neanderthals didn't live in the same type of environment or large enough communities to be at high risk of pathogens. Their knowledge of medicinal plants was comparable to that of contemporary humans. Neanderthals were in command of some natural drugs to speed up their recovery. One of the individuals from Shannon Cave was found to be buried with numerous plants believed to have medicinal properties, including yarrow. It is a natural antibacterial and fever reducer. Karen Hardy of the Catalan Institute for Research and Advanced Studies spent the past 6 years analyzing the calcified plaque left on Neanderthal teeth. She found the chemical signatures of yarrow and chamomile, which is also thought to have been an anti-inflammatory agent. Since these plants taste extremely bitter and have very little nutritional value by themselves, she hypothesizes that they were instead used for self-medication. Another analysis of a Neanderthal individual revealed traces of poplar, which contains the natural painkiller salicylic acid, and the mold penicillin, the source of one of our most successful antibiotics. While we can't be sure that this Neanderthal deliberately ingested these substances for medicinal purposes, it's telling that this individual suffered from a severe tooth abscess. The individual also had painful parasites which would have caused diarrhea. These plants were likely used to cure both of these ailments. Childbirth was also a particular challenge for these people. Just like in modern humans, the size and the shape of a Neanderthal baby's head and the mother's pelvis would have made unassisted childbirth very dangerous. Researchers are fairly certain some kind of midwifery was used to reduce mortality rates. Neanderthals had medicinal practices that were much more complex than anyone thought possible. These findings don't just sketch out a new branch into the history of medicine, they show that Neanderthal healthcare was remarkably similar to our own ancestors' strategies. Neanderthals are known to have used ochre. Ochre is well documented from 60 to 45,000 years ago in Neanderthal sites, with the earliest example dating to 250 to 200,000 years ago. It has been hypothesized to have been used as body paint. Analysis of pigments from France indicates that they were applied to soft materials such as hide or human skin. Modern hunter-gatherers use ochre for body paint, medicine, tanning hides, and food preparation. It is far from a fact that it was used as body paint, but if true, that would tell us loads about their culture. The body could have been painted for rituals or to show status. Containers apparently found for mixing ochre pigments were found in Romania, which could indicate a modification of ochre for solely aesthetic purposes. Beyond ochre, Neanderthals are known to have collected odd objects and may have turned them into pendants. A fossil sea snail shell, possibly painted red, was transported over 100 kilometers or 62 miles to a site in Italy about 47,000 years ago. Other shells found in Spain were painted in a variety of colors. At a site in France, beads made from animal teeth, shells, and ivory were found associated with Neanderthal bones, but the dating is uncertain. Other strange objects that Neanderthals collected included crystals and fossils. It is unclear if these objects were simply picked up for their aesthetic qualities, or if some symbolic significance was implied to them. These items were mainly quartz crystals, but other minerals include acericite, iron pyrite, calcite, and galena. A few findings feature modifications such as a mammoth tooth with an incision and a fossil numelite shell with a cross etched into it. A number of fossil shells are known from French Neanderthal sites. Another amazing find was a belemnite beak that these people had found and kept near. Further oddities found in their homes were objects we have interpreted as art. The mask of La Roche-Cotard is an interesting relic that was once owned by Neanderthals. It was made of a piece of flint with a bone pushed through a hole in the midsection. The actual function of this mask is unknown. It has been interpreted to resemble the upper half of the face, with the bone representing the eyes. It has been argued to not be art or even a mask at all. It could have served some function including tying knots or crafting tools. The exact purpose remains unknown. In 1988, American archaeologist Alexander Marshak speculated that a Neanderthal at the cave of Lourdes, France, wore a leopard pelt as personal adornment to indicate elevated status in a group based on recovered leopard skull, phalanges, and tail vertebrae. It's very interesting that they may have worn leopard pelts just as some Mesoamericans adorn themselves in jaguar pelts. Neanderthals are suggested to have used various bird parts as aesthetic mediums, specifically black feathers. In 2012, a study examined 1,699 sites across Eurasia and argued that raptors and corvids, which are not usually consumed by any human species, were overrepresented and show processing of only the wing bones instead of the fleshier torso. This indicates that the flight feathers were particularly targeted. Vultures, golden eagles, and ravens were all harvested. It is unknown how they would have captured such mobile animals. The earliest claim of bird bone jewelry is a number of 130,000-year-old white-tailed eagle talons found in a cache at Croatia. It has been speculated that they were used as a necklace. A similar 39,000-year-old Spanish imperial eagle talon necklace was reported in 2019. 17 decorated raven bones from Ukraine, dated to 43,000 years ago, were reported in 2017. Because the notches are more or less equidistant from each other, they are the first modified bird bones that cannot be explained by simple butchery. It seems birds were prized for some cultural or ritualistic reason. Feathers are widely believed among Native American Indians to signify a connection between the creator, the owner of the feather, and the bird from which the feather came from. Deeply revered, the feather symbolizes high honor, power, wisdom, trust, strength, and freedom. One would be a fool to say Neanderthals felt the same way, but since these feathers had no real survival purpose, they were likely used for personal adornment and meant something to them. There is some evidence that Neanderthals made musical instruments. The 43,000-year-old Divier babe flute from Slovenia has been attributed by some researchers to Neanderthals, and Canadian musicologist Robert Fink said the original flute had either a diatonic or pentatonic musical scale. The artifact is very controversial. Some claim it to have been made by modern humans, and others think it was made by a carnivore bite. The bone comes from a very young cave bear. The holes were most likely made from humans and seemingly deliberately spaced. Bob Fink claimed in his 1997 essay that the bones were consistent with 4 notes of the diatonic scale. This has also been met with a lot of criticism. It remains unknown whether it was a musical instrument, and it could have been used for another purpose. Regardless, if it was used for a musical instrument, that would be very amazing. The world-renowned artist Pablo Picasso once made a trip to the Stone Age cave of Altamira. This cave is filled with beautiful paintings of bison and other animals. They were made by Homo sapiens some 17,000 years ago. Upon Picasso's exit from the cave, he said, "In 15,000 years we have invented nothing." He also said, "After Altamira, all is decadence." He was blown away by such a raw expression of art. These people didn't have to create these paintings, but they took the liberty to depict their world on the walls of caves. Little did Picasso know that these were far from the first cave paintings. They may have been made in Europe before our species was even present in the area. As far as we currently know, our Neanderthal forebears created the first cave art of any human species. Art from Maltraviso Cave, also located in Spain, has been dated to 64,000 years ago, about 20,000 years before Homo sapiens were even in the area. It was long thought that these paintings may have been made by Homo sapiens, but after a new dating technique was used, it proves that these were the work of Neanderthals. Still, some people are critical of it, but I'll say this. Would a Neanderthal have to write, "This was made by a Neanderthal," or draw themselves on the cave wall for you to say it was made by a Neanderthal? We know that Homo sapiens were not in the region at the time, so I think it's very likely that these were made by Neanderthals, and scholars agree. The paintings found in Maltraviso are also very interesting. They show abstract symbols and even animals. Interpreting what these symbols might have meant is nearly impossible. Such an attempt usually tells you more about the theorist than the culture in question. We can undoubtedly say that this cave meant something to them. In order to create such works, they had to venture deep into the cave with the aid of a light source. They obviously did not haphazardly write on the wall as a child does in their textbook. A geometric ladder-like shape was made. Above it, over 100 dots of paint were placed. This would have taken precision and patience. 2 paintings of what have been interpreted to be animals fill 2 of the ladder's holes, both bulbous-looking herbivores. Then to the right of the work, a very strange and complex symbol was made. It does not look like a depiction of an animal or anything of the natural world, a purely symbolic creation. You can only imagine what the purpose of this painting was. Could it have been the seal of their clan, a depiction of a Neanderthal deity, maybe even a symbol that translates to a word? In truth, we will never know. In this cave, there also exists a couple red ochre hand paintings, a trend that would become very widespread throughout the Upper Paleolithic. Some hunter-gatherers in Australia still practice this ancient tradition. Likely the longest living expression of art, a mark of one's hand, the Stone Age way of saying, "I was here." Looking at walls of these handprints can sometimes be eerie. All of those people with a story just like you or I. Their lives as detailed and complicated as the one you're living right now. Neanderthals were no different. It seems they may have been pioneers of art. The discovery has opened the door to the possibility that other European Paleolithic art could have been created by our evolutionary cousins. Since sapien and Neanderthal occupation overlaps, we can only say that the art was Neanderthal if it was older than about 43 to 44,000 years ago. There's another cave in southern Spain called the Cave of Nerja. In it exist various works created over the past 40-some thousand years. Recent dating methods have shown that the paintings are over 42,000 years old. This has led some to speculate that they may be of Neanderthal origin. The paintings of 2 seals are among the oldest in the cave, which is an animal not commonly seen in cave art. Other cave art found at Les Mijaves and Cava de Castillo could have been made by Neanderthals. Both of these could have been made by Homo sapiens. However, Neanderthals were still present in Europe until about 35,000 years ago. We cannot definitely say which species produced these works. Another evidence of abstract art are strange stone circles found deep within caves. Tucked deep within a cave in France, there are stone circles made from stalagmites. They were made roughly 176,000 years ago. This completely rules out sapien involvement in their creation. Nearly 1,000 feet or 330 meters from the cave's entrance lie a large circle and a smaller semicircle. The larger one measured 22 feet or 6.7 meters across with evidence of fire inside. The fires were lit atop the stalagmite with charred bits of bone. The remains are very mysterious and researchers really don't know what to make of them. It is hard to determine any purpose of creating these structures besides just broadly labeling it as ritualistic. One of the most complex behaviors that Neanderthals have ever been speculated of demonstrating is the burial of their dead. The first evidence that Neanderthals buried their dead emerged from excavations in the 1950s and 60s. The cave yielded the remains of 10 Neanderthals, including one dubbed Shenandoah 4, which was found with clumps of pollen, suggesting the body had been deliberately placed in a grave and flowers scattered atop it. The finding was one of several lines of evidence that has led to the reassessment of Neanderthals as highly intelligent and social people. However, the idea of burial has been controversial, and the idea that flowers were placed on the grave seem even more unlikely. New evidence has reaffirmed the idea that Neanderthals buried their dead. Archaeologists in Iraq have discovered a new Neanderthal skeleton that appears to have been deliberately buried around 60 to 70,000 years ago. "We are quite confident," says Emma Pomeroy at the University of Cambridge. These new remains showed the upper half of a Neanderthal in an anatomical position. Pomeroy's team found multiple lines of evidence that the Neanderthal was deliberately buried, including the fact that the sediment layer around the body is visibly different from the layer below. Evidence of digging and replacement with different sediment is strong evidence for burial. Interestingly, we know that Homo sapiens were burying their dead at least 100,000 years ago, and these Neanderthals living in the Middle East might have encountered them. Perhaps the Neanderthals learned the practice from us sapiens. Personally, I don't like the notion that sapiens were the bringers of morality and complexity to the Neanderthal people. It is a very anthropocentric notion. It is likely we are doing this behavior independently. The graves of children and infants are especially associated with grave goods such as artifacts and bones. A newborn in France was associated with 3 flint scrapers, and one in Spain had a triangular piece of flint placed on its chest. Teshik Tash I in Uzbekistan was associated with a circle of ibex horns and a limestone slab used to support its head like a pillow. What is amazing about the remains is they show some sort of cultural or moral intelligence. Most animals do not care much about their dead. Elephants, apes, and some other animals show mourning behaviors to their kin, but burial is another level of cultural development. The buried individuals were loved by these people. This form of respect shows that they were passionate people who did not simply move on when a family member met an ill fate. It is difficult to establish a consensus regarding the language of these people. Given their degree of technical and cultural complexity, it is reasonable to assume they had a complex language comparable to the sapiens of the time. A somewhat complex language was likely necessary to survive in the harsh environment, with Neanderthals needing to communicate about topics such as locations, hunting and gathering, and tool-making techniques. Neurologically, Neanderthals had an expanded Broca's area, operating the formulation of sentences and speech comprehension. But out of a group of 48 genes believed to affect neural substrate of language, 11 had different methylation patterns between Neanderthals and modern humans. This could indicate a stronger ability in modern humans than Neanderthals to express language. This is not surprising considering that Neanderthals were overall less social than sapiens. They lived in smaller groups and interacted with others less frequently than us. The 1983 discovery of a Neanderthal hyoid bone used in speech production in humans in Capybara 2, which is almost identical to that of humans, suggests Neanderthals were certainly capable of speech. In 2015, Lieberman hypothesized that Neanderthals were capable of syntactical language, although nonetheless incapable of mastering any sapien dialect. If Neanderthals were not able to fully integrate into a sapien language, their hybrid children probably could. A sapien and Neanderthal hybrid at some point in prehistory was raised to speak a distinctly sapien language. This would have helped the two anatomically separate groups to possibly integrate in as little as 1 generation. It is fascinating that 2 species separated by hundreds of thousand years of evolution that spoke completely separate languages met together and created offspring. Neanderthals are thought to have lived in more sparsely distributed groups than modern contemporary humans. I touched on this earlier, but it is thought that there are no more than 10,000 individuals in Europe at any given time. Group size itself is thought to have averaged between 10 to 30 individuals, similar to modern hunter-gatherers. Though they typically lived in more isolated groups, they would still meet together and exchange members. Analysis of mtDNA of Neanderthals at Cueva de Cedron, Spain, showed that the 3 adult men belonged to the same matrilineal lineage, while the 3 adult women belonged to different ones. This suggests that a woman moved out of her group to live with her husband. British anthropologist Alan Pearce and Cypriot archaeologist Theodora Mutsu speculated that Neanderthals were possibly capable of forming geographically expansive ethno-linguistic tribes encompassing upwards of 800 people. This was based on the transport of obsidian up to 300 kilometers or 190 miles from the source. It was compared to trends seen in obsidian transfer distance in modern human hunter-gatherers. Still, some groups of Neanderthals were more isolated than others. The DNA of a Neanderthal from Denisova Cave, Russia, shows that she had an interbreeding coefficient of 1/8, which means her parents were related. Similarly, the inhabitants of Cueva de Cedron show several defects which may have been caused by interbreeding or recessive disorders. The social hierarchy of Neanderthals remains speculatory. It is sometimes suggested since they were hunter-gatherers of challenging big game and lived in small groups, there was no sexual division of labor as seen in modern hunter-gatherer societies. That is, men, women, and children all had to be involved in hunting instead of men hunting and the women and children foraging. However, with modern hunter-gatherers, the higher the mate dependency, the higher the division of labor. Further, tooth-wear patterns in Neanderthal men and women suggest that they commonly used their teeth for carrying items. The men exhibited more wearing on the upper teeth and women the lower, suggesting some cultural difference in tasks. It is controversially proposed that some Neanderthals wore decorative clothing or jewelry such as leopard skin or raptor feathers to display elevated status in the group. Valuable items found at burial sites may attest to this notion. It seems every individual was valued in their culture and everyone received medical care. Pop culture has long depicted Neanderthals as ape-like brutes, dumb-witted folk who couldn't care less about their kin. Hunter-gatherers in general have been depicted as cutthroat societies who will happily leave the weak behind for good, healthy people. This notion has been proven wrong time and time again by archaeological discoveries. The most fascinating display of Neanderthal compassion comes from the Shanidar cave in Iraq. Remains of a Neanderthal who survived well into his 40s were named Shanidar I. This man lived an excessively painful life. He had suffered a violent blow to the left side of his head at a young age. It fractured his orbital and left him partially or totally blind in his left eye. His teeth were abnormally worn, a sign of a degenerative disease. He also suffered from severe hearing loss, which left him partially deaf in one ear and likely completely deaf in the other ear. To add to all this, he suffered from a withered arm. Damage to his C5 vertebrae caused his right arm to lose muscle function. This arm was likely amputated later in life. If so, it is the earliest evidence of amputation on a living individual. The damage to his arm and vertebrae caused some paralysis on the right side of his body. To add to all this, he suffered from not one, but 2 broken legs. They had healed, but left him with a painful limp. Despite all these horrid injuries, he had survived well into his 40s. Given the time, that is ancient for a Neanderthal or even a contemporary Homo sapien. He would have needed the help of his tribe to feed him and help him with his various injuries. He was also very susceptible to predators, given his lack of senses and mobility. Regardless, he survived and likely died of natural causes. This level of altruism is hardly associated with the Neanderthal kind. Even some modern human hunter-gatherers have practiced killing off the weak and elderly for the good of the tribe. But these Neanderthals, all those thousands of years ago, valued this man. He was a part of their family, likely a father or a brother. At the tribe's expenses, he was kept alive. Far from knuckle-dragging brutes, these people were compassionate in the same way we are today. The Neanderthal era would begin to vastly change around 40 to 44,000 years ago. Their population had already been in decline for quite some time at this point. But a new threat appeared. A slim, dark-skinned group of humans was coming from the south. They were us, the sapiens. Sapiens had interacted with Neanderthals for a very long time. Not only were they closely related, so much so that some consider them a subspecies of us, but they also lived bordering each other. Neanderthals lived around the Mediterranean, but curiously stayed out of Africa for the most part. The closest they got was in southern Spain and the Middle East. But below this point, the lean, dark-skinned Homo sapiens roamed. And the sapiens too, for the most part, stayed out of Europe. However, there is evidence that the two groups occasionally crossed into each other's territories. There is evidence that they were there a whopping 150,000 years before once thought. A skull named Apnea 1 that is around 210,000 years old has been determined to be a mixture of modern human and more primitive features. It provides a rather grim story. The group that the skull belonged to inhabited the region for a short amount of time and then were swiftly replaced by Neanderthals. This shows us that sapiens did not originally thrive in Europe. It seems that those distant sapiens were just not ready for the challenges that awaited them. Neanderthals were already there, great predators existed, and the prey was different from what they were used to in Africa. Sapiens at this time were just as technologically advanced as Neanderthals. Actually, for much of our evolution, our technology and customs were indistinguishable from our contemporaries. It wouldn't be until after we had conquered much of Eurasia that some sapiens would finally move into Europe. As early as 100,000 years ago, our species was spreading across India and China. Even around 65,000 years ago, we conquered Australia. Finally, when we ventured into Europe about 45,000 years ago, we met Neanderthals. We then proceeded to mate with our stocky evolutionary cousins. DNA evidence tells us that most interbreeding occurred about 65 to 37,000 years ago. This coincides with our ideas about sapiens inhabiting Europe. This new wave of migrating sapiens seems to have been very dominant. Undeterred by beast or man, they quickly moved through the land inhabiting many environments. Their success was most likely due to new advancements in technology, social development, and perhaps more efficient and complex language. Neanderthals would quickly fade as sapiens began to spread across Europe. But what caused their light to dim? They had survived hundreds of thousands of years, thriving through beasts and ice ages alike. Why in the span of only 5,000 years did their entire species fade from the Earth? There are several proposed explanations. Climate change, sapien assimilation, and disease. The climate change model is based off their ultimate extinction happening in a Heinrich 4 event. Heinrich 4 events are periods of intense seasonality. They have historically been associated with massive cultural turnovers and collapses in European populations. It is speculated that this event would have depopulated Neanderthal areas which were then inhabited by sapiens, basically making their species more susceptible to sapien takeover. Typically, these events were survivable, but with a new migrating population, they were pushed out of their range. The next and probably most influential factor was sapien assimilation. Neanderthal population by nature was spread thin compared to that of our species. Sapiens lived in larger groups and were connected with other large groups. The introduction of our species in the area would have increased the population, and Neanderthals would have only made up a fraction of this total population. Subsequent breeding would have effectively bred out Neanderthals from existence. It is a fact that we bred with these people, but not extensively. Still, if our population was truly much greater, even extensive breeding would leave less of a trace considering the population size. The last factor was disease. Since sapiens lived in larger populations, diseases thrived much more effectively. The introduction of African pathogens to these isolated people may have had a similar effect when Europeans first encountered the Native Americans. However, DNA evidence tells us that Neanderthals had an adaptive and strong immune system. Regardless, our diseases would have not been pleasant to deal with. It is also possible we transmitted a spongiform disease to Neanderthals. This disease makes cannibalism a deadly practice. Ingesting brain matter from someone with a contaminated brain can be fatal. Since we know that some Neanderthals were cannibalistic, this disease could have swiftly wiped out some of the population. The last cause may have been violence. Sapiens throughout history have been notorious for not being the most acceptable. We could have committed mass genocides, some of which may have not been left in the fossil record. Neanderthals were strong and fearsome adversaries. In a one-on-one fight, the sapien with similar technology would have been likely submitted by their superior strength and athleticism. But a band of 300 sapiens would easily wipe 30 Neanderthals off the map. Our social organization made us vastly militarily superior to Neanderthals. Even so, we do not have evidence that we fought them or committed any of these genocides. Still, evidence could be lost to time. We do have some evidence that Neanderthals fought with each other. A skeleton from Larache in Perros, France has a healed fracture on top of the skull apparently caused by a deep blade wound, and another from Shandadar Cave, Iraq, found to have a rib lesion characteristic of a projectile weapon. Their extinction was certainly caused by a complex array of things. They would fade throughout the world and were mostly extinct by around 39,000 years ago. Some may have survived as late as about 35,000 years ago. Evidence of later survival comes out every once in a while, but is usually just found to be dated incorrectly. Even with some isolated populations, it is generally thought that they were extinct by 30,000 years ago. Despite dying out, they still live within us to this day. Their DNA lives inside of nearly all modern humans. In modern Europeans, 1 to 4% of their DNA is Neanderthal. Some Asians have as much as 3 to 7%. It is thought that pre-agricultural Europeans had similar percentages to modern Asians, but it was diluted by a group of people who had split off before Neanderthal integration. Even sub-Saharan Africans may have had very small amounts of Neanderthal DNA, up to about 0.5%. Typically, Neanderthal genes in the modern genome are related to immunity, 25% in Europeans and 32% in East Asians. In all, approximately 20% of the Neanderthal genome seems to have survived in the modern human pool. However, due to their small population and resulting in reduced effectiveness of natural selection, Neanderthals accumulated several weakly harmful mutations, which were introduced to and slowly selected out of the much larger human population. The initial hybridized population may have experienced up to 94% reduction in fitness compared to contemporary humans. A 2017 population focusing on archaic genes in Turkey found associations with several diseases. Nonetheless, some genes may have helped modern human Europeans adapt to the environment. Genes associated with lighter skin and hair may have been descended from our stocky cousins. However, light skin did not become prevalent in European sapiens until the Holocene. Neanderthal genes have also been implicated in the structure of the brain. Nonetheless, a large portion of surviving integration appears to be non-coding junk DNA with few biological functions. Due to the absence of Neanderthal-derived mtDNA, which is passed on from the mother to child in modern populations, it has been suggested that the progeny of Neanderthal females who mated with modern human males were either rare, absent, or sterile. That is to say, admixture stems from the progeny of Neanderthal males with modern human females. Due to the lack of Neanderthal-derived Y chromosome in modern humans, which is passed on from the father to son, it has also been suggested that hybrids that contributed ancestry to modern populations were predominantly female, or the Neanderthal Y chromosome was not compatible with Homo sapiens and became extinct. So overall, most hybrids were produced with a Neanderthal male and a sapien woman, and most of them were females. The remains of a 40,000-year-old sapien studied in 2015 was found to have very high levels of Neanderthal DNA. It was found that he had a Neanderthal ancestor about 4 to 6 generations ago, likely a great-great-grandfather. Neanderthals went extinct, but they live on in you and I to this day. They were a great species that pioneered many things. We really don't give them enough credit, mainly out of our arrogance. Thankfully, discoveries have unveiled that they were very human. They buried their dead, had culture, and they even cared for each other in the same way that we do. Though they are gone, I am thankful we know so much about our stocky relatives. Further discoveries will shed even more light on their history, and I am excited to see what they find next.